Hello all. Today we are going to see about an important topic in a data sources called a double linked list. Before double linked list, there is a single linked list. In a single linked list, every node has a link to its next node in the sequence. So we can traverse from one node to another node only in one direction. We cannot traverse back. This problem can be overcome by using a double linked list. In double linked list, every node has a link to its previous node and next node. So we can traverse forward by using the next field and can traverse backward by using the previous field. Every node in a double linked list contains three fields. Their data part, the next part, and the previous part. Okay, there are some important points which should be remembered. In double linked list, the first node must be always pointed by head. Always, the previous field of the first node must be null. Always, the next field of the last node must be null. There are three basic operations which are going to perform in the double linked list. They are insertion, deletion, and traversing, which is also known as the display. The insertion can be performed in three ways as follows: insertion at beginning of the list, insertion at ending of the list, and at specific location in the list. Here we are going to reduce our scope only to the first two those, that is inserting at the beginning of the list and end of the list, and deletion from the beginning of the list and deletion from end of the list. Okay, first we would see over the algorithm of the inserting at beginning of the list. There are only four steps in this inserting at beginning of the list. They are: step 1, create a new node with given value and new node previous as null. Check whether list is empty, that is head equal to null. If it is empty, then assign null to new node, which then applies to next and new node to head. If it is not empty, then assign head to new node, that is next and new node to head. Inserting at end of the list, there are 6 steps in this. Create a new node with given value and new node where next has null. Check whether list is empty, that is head equal to null. If it is empty, then assign null to new node, that is previous and the new node to head. If it is not empty, then define a node pointer temp and initialize with head. Keep moving the temp to its next node until it reaches to the last node in the list, until temp, that is next, is equal to null. Assign new node to temp, that is next, and temp to new node, that is previous. And now we are going to see about the algorithm for deleting from beginning of the list. There are 6 steps. Check whether list is empty, that is head equal to null. If it is empty, then display list is empty. Deletion is not possible and terminate the function. Step 3. If it is not empty, then define a node pointer temp and initialize with head. Step 4. Check whether list is having only one node, temp, that is previous, is equal to temp, that is next. Step 5. If it is true, then set head to null and delete temp, setting empty is list conditions. Step 6. If it is false, then assign temp, that is next, to head, null to head, that is previous, and delete temp. And the last algorithm is deleting from end of the list. This contains the 7 steps. The step 1 is check whether list is empty, that is head equal to null. Step 2. If it is empty, then display list is empty, deletion is not possible, and terminate the function. Step 3. If it is not empty, then define a node pointer temp and initialize with head. Step 4. Check whether list has only one node, temp, that is previous, and temp, that is next. Both are null. If it is true, then assign null to head and eliminate. Step 5. If it is true, then assign null to head and delete temp and terminate from the function, setting empty list condition. Step 6. If it is false, then keep moving temp until it reaches to the last node in the list, until temp, that is next, is equal to null. Step 7. Assign null to temp, that is previous, and next, and delete temp. Okay. Now we will move on to the coding part. I have previously coded the double linked list implement. And these are the header files which are using HTML include stdio.h and stdio.h. And I have declared the structure with elements info as a data type int and node structure with having a pointer variable preview and pointer variable next. Here I have declared the function called void traverse. This node will perform the function of displaying all the elements in the double linked list. This is the code. Is not equal to null. It will print list is empty. Else, after the struct node start temp is equal to start. By assigning start to temp, we are moving the further coding. While temp, which is not equal to null, then this statement, printf statement, will display each and every element in the double linked list. Insert at front. This block of statement is used to insert data at the beginning of the node. At the beginning, we are declaring a data variable with the type int and a temp as with a structure node pointer. Then we are using a malloc function for dynamic memory allocation. Then we are printing enter number to be inserted. And with this data variable, we are getting the data which is needed to be inserted into the node. Then after this, this function will execute inserting elements at the end. This is same as that of the insert at front, except here condition is occurring where if start equal to null, then we are assigning temp to start. Else, here giving a while condition where trav of next. That is in the trav structure we are pointing to next, which is not equal to null. Then trav equal to trav pointing to next, and then these two lines supports are getting executed. Why delete first? This is the element which is deleted at the beginning. Then we are assigning a value, a variable with a structure node pointer. If start equal to null, then we are printing list is empty. Else, we are assigning start with temp and start tending next to start. And then this if block is getting executed. With void delete end, we are performing this we are performing the deletion of elements at the end of the start node start temp. If start equal to null, printf list is empty. Temp equal to start. While temp ending next not equal to null, temp is equal to temp ending next. Then this if and this block will be performed. We are performing all of these functions using getting choice from the user as 1 to see list, 2 for insertion at starting, 3 for insertion at ending, 4 for deletion of first element, then 5 for deletion of last one, 6 to exit. And then we are getting a choice from the user, and using which case we are accessing each and every functions. Now we will execute the code part. Now I want to see the list. The list is empty. Then I want to insert an element at the end, starting. I will enter 12. Then I want to insert an element at the end, so I am getting 3. First element. Then by giving 5, I am deleting the last element. Then I want to see the list now. Remaining data is equal to 32. And now I want to exit the code, exit the program. 6.